it's a bit tedious. I'll show you at the class. Okay, now, you'll notice we all got the same graph, didn't we? We all got the same exact graph, I'm guessing. You guys all good?
Yep.
No, yeah, what's up? What's up?
I have something in L2 or L1 and I can't figure out.
Oh, this guy right here? Oh, turn that plot 3 off. So go up here, press enter.
I have something in L1.
Oh, so your data's in L2. Oh, well then all you gotta do
I have,
is go here and change this to L2.
okay.
And then we go 09. Look at that.
Okay.
Yeah, so what Gail had, and this is going to happen eventually, she put her data in L2 instead of L1. You can put it anywhere you want. Doesn't matter to me what list you put it in, so long as when you go to set your plot up, you tell it right here where your data is. Is that fair?
Right.
L3, L4, age, right? You can even name it age if you want to, as long as that's pulling from that. It doesn't matter what you name it.
So could I add all the lists together there?
No. It has to be in one list. It doesn't matter which list, but it has to be in one. I wish you could. Logically, you should be able to, right? Now, once you get to here, you're going to have 7 bars. Or 7 places for bars. There might not be anything in the 7th bar. The reason you have 7 bars is because TI decided that's how many they want you to have. I don't have a good answer other than that. So, we're going to fix that in a second. But here's why I want to fix it. Press the trace button right now, which is between zoom and graph. We're going to be using all these buttons by the end of the day, just like you did in Math 95 if you took Math 95. Now what this does is it puts, I call it the spider, the little guy Blinky, okay? It puts him on the histogram, and it gives you some information. It says min equals negative 58, max is less than negative 44.8333333, n equals 1. Now, that's TIEs. Do you know what it's trying to tell you? It's TI language, but what's it trying to tell you?
The minimum loss is negative 58.
The minimum on record is negative 58. What's this?
The maximum.
The max is about negative 44.8. What's this mean? This is tricky, because it doesn't mean N. What it really means is F.
Oh.
Oh, okay.
It means, yes, a frequency of 1, which means one person, did what?
Lost negative 58 pounds.
Lost between either negative 44.8 and negative 58. That's what it means when it says that. It doesn't tell you where they are in that range, right? It just tells you one person was in that range. This is always the problem with the histogram, correct? As soon as you put the data in like this, you don't know the specificity. You just know they're between these 2 weights, negative 58 and negative 44.8, negative 45. All right, ask me that question.
No, doesn't it correspond to the y value?
It does. Yes, ma'am. Yes, ma'am. So this 1 right here will come across there. That's a 1. Yes, yes, yes. And we can change that, which we're going to get to in a minute. But yes, it does correspond to that directly. Absolutely. Now, I use the word scooch when I move right to left on a graph. So scooch right 1 by pressing the right arrow, 1. Now, we are between negative 44.8 and negative 31.666666. And F is 3. Well, it says N, but that means 3. So 3 means 3 people lost between negative 31.7 pounds and negative 44.8 pounds. And if you keep scooching, they keep updating for you. 12 people are in that range, 10 are in that range, and so forth and so on. And this is fantastic, because it gives us those breakdowns of bars. Now, a couple of you have asked me a very, very good question, and I've been very, very evasive in my answer. How many bars should we have in a histogram? Are these 6 enough? Well, I don't know. It depends on what you mean by enough. What was the real reason we graphed this histogram? Do you remember? Somebody just said it over here.
So look at the shape.
To check the shape of it.
Lisa.
Lisa, thank you. To check the shape to see if it was a bell curve. Kelly. Kelly?
Yeah.
Kelly, yeah. To check if it was a bell curve. Yes. It looks kind of bellish, doesn't it? So if all you want to do is check the shape, this is good.
Doesn't matter.
It doesn't really matter as long as what you don't want to do is have like one big bar that's 35 high. Not a bell curve. Well, how can you tell? Everything's in one bar between negative 58 and positive 50. Like that doesn't. So that's not refined enough. This is probably refined enough to check the shape.
But you can make it bigger.
Yes, you can make more bars or fewer bars, and you can do that in the TI. That's what I want to do the next couple minutes here is mess with the bars, because personally, I can't stand these numbers. These 0.3s and these 0.6s, they make my head hurt. I like to go, notice how I constantly go to run. About 75%, It's about 15, it's about 16. I tend to slough off some of those numbers, especially when I'm not allowed to have that kind of precision. I got no right to say 7.833333. The numbers given to me were the nearest whole number. I got no right to go that level of precision in the calculation, do I? Not really, not with sig figs. So, here's how we mess with that. Which button haven't we haven't pressed window yet, have we, up top? We've pressed every other button except window, I think. Press the window button now. I did it again, I'm sorry, I'll stop doing that. This is where we can control the bars of the histogram. So you see that min, or that X min at the bottom, that negative 58? That's great, but I'm gonna round that down to negative 60, if that's okay with you guys, just to make it a nice power of 5 or 10 or something like that. Not power of 5, multiple of 5 or 10. The X max is 34.1666666. Which will we make it?
34.
34? Can I make it 35 just because I
Sure.
can't divide? I can divide by 5 better than I can divide by 7 or 17. Is that fair? Lloyd said 34. Perfectly logical. Can I make it 35? That way it's a multiple of 5. Kind of makes me a little bit easier. Makes my mental math easier to do. 17 is harder to divide than 5. Now, here's the kicker. What do you think X scale governs? Lisa's like, I don't know, it's ugly though. It's how wide each bar was. 13.1666. That's a weird number, isn't it? But that's because the TI has this algorithm that it kicks out. We can change anything we want to. What do we want to change it to?
10.
10. I heard 10 in stereo on triplicate. 10 it is. 10. Let's start there. We can mess with the Y's too. This is what Anna was talking about. But let's start with this. Now, once you start messing with the window, you don't want to press that zoom button again. Simply press the graph button this time. And you'll get your updated histogram with your new width bars. Huh? Nice, huh?
Wait, press what?
Just the graph button all the way to the right, and now you get your updated histogram. Tell me how it's similar to the one we just had.
It's a bell curve.
Oh, I got a call for a bell curve? Is it perfect?
No.
Will it ever be perfect?
No.
If it is perfect, what happens?
Fill the line.
Harrison Ford gets chased by the one-armed man, just like in The Fugitive.
It represents our data a little bit better to not be so bellish looking because our data isn't really.
I like that. Even the original one looked a little skewed, but this one gives us a little more character, a little more personality. We get this guy. Here's your negative 58, right? He's now popped out, separated. And then you get this. There's definitely a little bit of a miss here. There's only 35 people in the sample. If we packed more in, I'm guessing this would flesh out more. Got the tail, So we're addressing your concern from earlier, Kenneth, which is so good, about the high variability. Yeah, but for every high, there's a corresponding low. And where does the hump of the curve appear to be? Where does the hump, if you were to draw a curve, where does the hump appear to be? B-ish. B-ish. Lisa, go ahead, be brave.
No way.
No way, no, okay, don't be brave. That's okay.
Near the middle.
Define middle.
Uh,
That's very Riverdance, I apologize.
I say left of middle.
Oh, you guys are saying middle, you're saying this. I was thinking statistical middle.
no, I was thinking statistical middle.
You were thinking this, huh? And if you think about it, this is one of the reasons I love that you guys picked 10 for a measure. Because here's 0, here's negative 10, here's negative 20, there's your average right there.
That's what I was thinking.
Yeah, good for you, absolutely. There's your average. And if you think about it, that's where you'd have to hold the cookie tray to balance them. Negative 15, basically. What's cool is, watch this, you don't have to do this if you don't want to. You can then get into your window and change your scale to say 5. Then you get twice as many bars, but your balance point's still at negative 15. Notice how when I changed it to that, when I changed the scaling to 5, it still maintains the bell shape Lloyd mentioned, but we're getting more refined. You can make these widths anything you want. You can make the width 7.5 if you wanted to.
That's cool.
Yeah, it's totally badass. You could totally break up, I use that word a lot in this class, I apologize. You can break it up any way you want to, but the average is still going to be there at the middle point. This is what's so nice about technology, allowing you to do that. And this is one thing the TI actually has over Excel. It makes it so easy to do this on the fly. Excel, you have to re-sort your data each time before making a histogram. It's kind of a pain. Go ahead, Candace. I'm going to go back to what you guys had, if that's okay. Did you guys like 10?
Yeah.
We'll go with 10. Go ahead,
Is this one
Candace.
of those samples where we would want to drop off the lowest and the highest?
Let's not worry about that right now.
Okay.
I do want to worry about that. Candace is saying, is this one of those samples where we should trim the mean? I got 2 answers for you. First of all, let's not worry about that right now. Because the idea of removing data is always, it's always ishy. Fishy, ishy, wishy-washy. It's always tricky. But I'm not even worried about, it was Gail, right? You said if you got an outlier, the average is going to chase that outlier. I'm not super worried about it because the first couple words I heard when I said, what's that shape like, were bell curve. I didn't hear skew. Nobody said, oh, it's highly skewed, right? If somebody said, oh, it's highly skewed, then I'd be like, maybe we got to talk about getting rid of that one, getting rid of those outliers, but nobody went there. You guys went with bell shaped, which is, again, why I was so tickled to find this data. Did anybody think, when you looked at this block of numbers on the data sheet, that was going to look like a bell curve?
No.
Why would you assume that, right? Why would you assume it's a bell curve? That's why you look at it, to see if it is, and then see how to decide whether it goes Gesundheit. Yeah. Fair? Good. But I don't want to get too far from that question. It's a great question. Cool? All right. Now, I have not forgotten what Anna said earlier, which was 75% of folks lost weight. What's the problem with just, and again, we mentioned this earlier, what's the problem with simply saying 75% of folks lost weight? What's the problem with doing that?